Hey everybody, so in this video I'm going to be going over the very easy crypto challenge perfect synchronization from the Cyber Apocalypse 2023 CTF from Hack the Box. So I've already downloaded the files, so let's just jump right into it. We see we have two files, an output text file and a source Python file. Looking in the source Python file, we see in the main function that some kind of cipher is being created. Some message is being encrypted, and the output of that message, every item in that message is being converted to hex and joined with a new line, and then all of that is being written to the output text file. So the output text file should just be a bunch of hex strings, which it is. We see there are 1,479 of them. So if we dig a little deeper and see what the cipher is and what kind of encryption is actually taking place. First off, we see this message that we're encrypting is coming from secret, which we don't have access to. I mean, that's sort of the whole point of the challenge, right? Is we need to figure out what this message is. But we are given this assert statement here that tells us that every character in the message is either going to be uppercase or it's going to be one of these four characters, the brackets, the underscore, and a space. So we know the character space for this message is 30 characters, right? The 26 letters and then these four. If we look into the cipher, it is creating a 15-byte random salt, 16-byte random key, and then AES is being used with that random key under mode ECB. And the encryption function is taking every character in the message, it's prepending it to that salt. It's converting it to a byte string and prepending it to that salt, and then it is encrypting it. So the output that you're getting from encryption will be a list with each item being the encryption of a character prepended to the salt, run through AES under this key in ECB mode. So you don't really need to know anything about how AES works or anything at all for this challenge other than, well, one helpful fact is just the understanding. So AES always works on 16-byte blocks, which is why we have a 15-byte random salt and then our 1-byte character prepended to that. So that gives us our 16-byte block. But the key to this whole challenge is this right here, this ECB mode. So in AES ECB mode, what it does is it encrypts a block, and the output of that block will always be the same. If the input is the same, the output will always be the same if it's encrypted under like the same key. So that's kind of an inherent weakness of this mode, which is why it's not really used and a bunch of other modes were developed, because it leaks information, right? We might not know what the encryption of the, say, the letter A with that 16 or 15-byte salt is, but every time an A gets encrypted, it will always produce the exact same output. So what this challenge is essentially, well, not essentially, it's a more complicated substitution cipher. But instead of substituting letters, so like say, normally maybe an A maps to G and a B maps to, Z or whatever it is you want to do. Instead, now we're mapping A to a 16-byte hex string. We're mapping B to a different 16-byte hex string. So we don't know what's what, but every A that gets encrypted, because the salt never changes, even though we don't know what it is, it's always going to produce the same output. So we can see here there's different frequencies, right? Like, so this one gets used quite a bit. This one a lot, this one a lot, this one a whole lot. So we're going to break this challenge the same way we would pretty much any substitution cipher, is we're going to use frequency analysis, which, if you're not familiar with, is essentially just we're going to use the facts we know about the English language and what we can know about these outputs, right? So like say in English, E is the most common letter. So we would expect in a message of, the encryption of a bunch of letters that E will be the most common output. So what we're going to do is just count all these up and then analyze the frequencies, and then we can map those to the most likely what they're most likely going to be. So like, the one that's the most often, we'll assume is an E, and then we're just going to go through and do that until we eventually recover the message. So let's go ahead and create a Python script to solve this challenge. And the first thing we need to do is import, we need to get all these read in so that we can count them up. So let's do that here. Open it in read-only mode. Oops. We'll call it outputs. So we're going to read the whole file, and then it's split up on new lines. So we'll split it by new lines. And what this should give us is a list of 1,479 elements, right? All of these. So if we just check and make sure we did that right. We did not. I made some kind of error. Oops. I had to save the file first. That's indeed what we see. So now we want to count all these, right? We need to know how many times does this one happen? How many times does this one happen? And then that way we can start to figure everything out. So there's a bunch of different ways we could do that, but the easiest would be using the counter function built into the collections of Python. What this essentially does is it just takes a list and does exactly what we want it to do. It makes each one of these is going to be a key. It's subclasses like the dictionary. So each one of these is going to be a key, and then the number of times it occurs is going to be the value. So we'll call this our frequencies. And we'll just create a counter object, and we'll use that list of outputs to do that. So let's go ahead and print our frequencies. And from collections. So we see here, that is indeed what we get, right? So we see that this one is used 230 times, this one 142. So I said E is the most common letter, which is true, but in a like a volume of text or whatever, space is the character that occurs the most often, and by a large margin, which we see here. This is being produced a lot more than the next highest one. So this is most likely our space, and then I would assume that this one is probably our E. And then another important feature is we know that all the flags are in the form of HTB, open some stuff in it, and then close, right? So we know, right, our goal is to get a flag. So somewhere in that message must be a flag. So somewhere in this message, there has to be an open bracket and a closing bracket. Well, if we look at the occurrences of these outputs, we see that these two right here only occur once. So just by process of elimination, that means one of these must be the open bracket and one of these must be the closed bracket. And then when we find those, we'll know that the three directly preceding it are going to have to be an H, a T, a B. So we've already got a decent amount of information to go ahead and start analyzing and trying to figure out what the message is. So what we need to do now is kind of make a way for us to easily sort of see it and get a representation of it. So let's go ahead and we'll create a dictionary where we'll call it our mappings. Actually, let's call it subs for substitutions, just because that's shorter and less to type. So we're going to create a dictionary. We are going to make our dictionary come from the keys of, we want we want each of these to be a key. Well, these are keys in the frequency dictionary. So we could say frequency keys. That will just give us all the keys from the frequency dictionary, and we're going to use those same keys in our substitution. And what we're going to do is, since initially we don't know what anything maps to, we'll map everything to a question mark. So now what we can do is we need a way to make our message. Like if we did it, let me think. If we did it such that if we said for every character in output, right? Output is this 1479 long thing. That's the message we're trying to break. So if we said for each of those, let's substitute what X is, what we have it mapped to. So we're taking each one of these and then we're checking to see what it maps to, and we're mapping it to that. And that would give us a list of everything, right? So if we printed this out, actually, we'll make it a message, and then we'll print the message, right? This should give us a list of a whole bunch of question marks, which is what we have. But let's make it a string so it's easier for us to like read. So we'll just join all the items in that list with a null space so that they're all just smushed together. And so now we can see our message here before we have anything to map, and it's all being mapped to question marks. So let's go ahead and put in some of the stuff we know, right? So let's say, we know that we want to map we said one of these is the open bracket. We don't know which one, but we know the open bracket has to come first, so we can check that. And we're going to map it to the open bracket. And we said that this one is the closed bracket. So we're telling our dictionaries, we're saying, hey, map this key to this value. And then we could go out and print that. And we see here, it looks like we picked correctly, right? Because the open one has to come first. So it looks like that is where the flag is in this big long message. So we know that's whatever this is going to be a B. That's going to be a T, and that's going to be an A. So, but we also have some other things. Let's go ahead and do, this one's pretty clearly a space. Most likely. And we said the next one was most likely an E because it's quite a bit higher than the next one. And let's go ahead and print that out and see what it looks like now. And we see it starts to take more shape and look like actual text. And if we go down to where's that flag? So right here, it looks like our flag is starting to take shape. So we know that this is a H, a T, a B. So we need to figure out what index this occurs at in this string, and then we can look in that outputs, and we'll know that that is the hex string that we're going to map to the letter A. So what we can do is, we want to take our message and we want to find the index of where this occurs. All right, let's print that out. That'll tell us the index. So we know at position 1095 is where this string starts. And so we know position 1095, whatever that is in the output, Like we could then print outputs. We know that this we're saying is our H. We can go ahead and combine that because we don't actually care what the position is. We just want to know what the string is. So we could just say outputs, right? And then that should, that should go ahead and just print that string. So then what we can do is come up here and start mapping stuff. Oops. And we said that is an H. We don't need that anymore. Oh, we get, so now we get an error because we're looking for this string and it doesn't exist anymore because now we filled in the H. So let's go ahead and, I mean, we don't even need all this, right? Because we know this is the only occurrence of that. So we could just get rid of all that. And then let's find out where that is. So that is going to be this one. So then we can just keep, and I'll just do a couple of these because no one wants to sit here and watch me figure out all of them. And then we want to know what this one is. And we said that was going to be a B. And then essentially what, oops, what did I, oh, because it's doing the same thing. It's looking for that. So let's just comment that. So essentially we're just going to go through this and use what we know about English to try and figure stuff out. So like this right here, this one here is probably an A, right? That makes the most sense. We see this right here, that's probably a Y, right? Like BY is kind of probably the only thing that works there. Let's see, what are some other ones we could start to figure out? Like that, this one looks like, I mean, given what challenges they're about and stuff, that's probably a letter. So that's probably an L, that's probably an R. Yeah, so letter. So we would just essentially just keep doing that. So like, let's figure out what this one was. So we want to know, we're saying that's an A. So we want to find out where that started. And we're going to say that's an A. And if we look at our frequencies, right, and A should be pretty common, we see actually A appears to be the second most common one. So like normally, I think T is the second most common, and we actually have T as 6/8. Which looks like it should be, I can't see it. Oh, right here. So it's the third most, well, letter, not space. So essentially we can't just like automatically map everything. Like sometimes in some of these challenges, you can just take, the frequencies will be so close you could actually we could automate this whole thing. Here we can't. We're going to actually kind of have to go through it and figure it out and do it kind of step by step. So I'll just do this one and then. So essentially you're just going to keep doing this until you will figure them all out. And there's probably like, an easier way to do all this, but it's a CTF. So you're just kind of doing it, whatever method kind of works the fastest for you to like work up in code. So that's kind of clunky to have to keep commenting out and running it and commenting it out, but whatever. So yeah, essentially you just keep doing that. I went ahead and have already done all that. So just to prove that I'm not making things up. Delete these. I went and did all the letters. It comes out to this. And if we print it, we see we do indeed get a whole bunch of text that actually makes sense. And in that text is our flag. So yeah, hopefully all that made sense and it was pretty straightforward. I don't know if anyone actually made it all the way to the end of this. Yeah, thanks for listening. I hope you got something out of it. If you did, it'd be cool if you wanted to like or subscribe or do any of those things that everyone's always telling you to do on YouTube videos. Otherwise, yeah, take care.